Hello everyone, welcome back to Think, Solve, Reflect. I'm Rashid, and today's objective is to build a mindset around what Apollo 13 teaches us about teamwork. So the story happened in April 13, 1970, more than 200,000 miles from Earth. There were three astronauts that heard a loud bang. There were warning lights illuminated, oxygen was escaping into space, and they were on their way to the moon. The power was disappearing or powering down. The mission to land on the moon was over due to this incident. So now the mission to survive has just begun. Uh, if you ever, if you've ever heard the famous words, "Houston, we've had a problem," or "Houston, we have a problem," you know kind of story. But Apollo 13 isn't remembered because something that went wrong. It's remembered because hundreds of people worked together to bring these three brave astronauts safely home. And that's kind of what I want to get into here. And today we will explore what Apollo 13 teaches us about teamwork and why engineers know that the best teams aren't the ones that never face problems, they're the ones that solve them together. So that's kind of the important takeaway here, and I'll get to it by the end of the video. So when the explosion damaged the spacecraft, everything changed instantly. The original mission plan to change is it's not, and it the original mission objective or goal is doesn't matter now because uh, the mind is gonna change or the goal is gonna change from landing on the moon to surviving and returning back safely home. So instead of asking how do we reach the moon, mission control had to ask how do we bring everyone home alive. So you see that's a big change. The constraints changed, and this is what we understand in engineering. It's not only about if the objective changed, also the constraints did they change as well. The timeline changed, and that's another thing you ask how much time we have. Um, and good engineers recognize that when reality changes, the plan must change with it, which means must adapt with it. Holding on to the original plan would have been disastrous, of course. It will not work because everything has to go as planned to make the objective or the initial objective to the moon. So the adaptation became the new mission. And in daily life, this is a big takeaway to understand from here is the adaptation is the new mission almost every day. It's tempting to imagine one brilliant engineer solving the problem. So here people would say, "Oh, okay. So who's this uh, one person who came up with the solution?" That's not what happened. Specialists from many disciplines work together. You have flight controls, you have engineers, you have astronauts, you have navigation experts, you have life support specialists, and there are probably other members in the team. Each person understood only part of the system. Each person had certain expertise. So only by combining their knowledge could they understand the whole picture. Engineering is rarely about individual genius, it's more about coordinated expertise. So the strength of the team came from the diversity of its knowledge, and that's important. So maybe mention this again before I move on. It's the engineering here is not about this individual, the genius or super engineer or something. It's more about coordinated expertise, and the team depends on the diversity of its team members as far as what knowledge and expertise they have. So one of the Apollo 13 greatest challenges involved removing carbon dioxide from the spacecraft. So carbon dioxide became a toxic substance. The astronauts had enough oxygen, but carbon dioxide levels were rising to dangerous levels. The replacement filter didn't fit. The spacecraft has square filters. The lunar module required round ones. So you see now there is a new challenge they're facing. And engineers on Earth gathered the same materials available to astronauts, like what they have on board, like plastic bag, manuals, cardboard tape, um, like duct tape or something, hoses, and worked together to design a practical solution. They didn't wish for better tools, they used what they had. That's an engineering mindset. You see, that's very important in engineering to understand. And when resources are limited, creativity becomes essential. Constraints don't stop innovation, they often inspire it. So this is a saying we usually say, uh, say that constraints, they don't sometimes make us stop making something. They actually inspire creativity and come up with new solutions. So in crisis, confusion, of course, can become just as dangerous as the original problem, because now time is not on your side. A lot of things are not on your side, and you have to act, and you need to know what your solution works. That's the big deal here. And any misunderstanding can be a big problem. So confusion can become very dangerous, uh, and the mission control communicated clearly, and responsibilities were well defined. So responsibilities, who's going to do what, it becomes more important, and it's important to have good communication when and avoid confusion. So people listen before speaking. That's very important in engineering. Information was verified. There is no misunderstanding to what was said. Assumptions were challenged. Nobody was trying to prove that they were the smartest person in the room or they have the best option. Everyone was focused and solving the problem. And that tells us effective teamwork is not about everyone talking, it's more about everyone understanding, having clear communication, trying to reduce errors, and build trust, which keeps complex system functioning even under big pressure. So most of us will here maybe not fly to the moon or something, or some of you will fly to the moon, but we need to understand what's going on in this story to bring it back to any other daily life incident or engineering, and we are and or a challenge that we expect or unexpect. Um, and a group of project that isn't or a group project that isn't going well, or emergency, or cyber incident, or a setback to a business, or a research not going well. So there are a lot of things that could happen, but we need to remember that Apollo 13 didn't waste time or energy in asking, okay, whose fault is this? Now that this happened, whose fault is it? Instead, they ask, what information do we have? What resources remain? Who can help? What's the next best step? You see, so there is a process. It's just like you're solving a math problem here. And that's why I love math, because it guides you into thinking, or it gives you a clear sense of thinking when it comes to problem solving or or any other situation or any other challenge like this one. So great teams move from kind of blame to problem solving. Somebody will say, well, is accountability here important? But that's not, there is time for everything. And that's what's important to understand here. Accountability or something else, there is maybe a time for it. But when in a moment of crisis, when time is not on your side, the team needs to pull together to solve the problem. And that's what's important here. And that's what engineers do. So Apollo 13 reminds us that success isn't measured by whether everything goes according to plan. Sometimes success means adapting when the plan falls apart. The mission didn't achieve its original goal, which is walking on the moon. However, Apollo 13 is remembered as one of NASA's greatest successes because everyone returned home safely. Engineering teaches us that success isn't always doing exactly what you intend to do. Sometimes success is protecting what matters most when circumstances change. The best teams don't panic when problems appear. They communicate, they adapt, they solve together. So that's a simple shift, or that simple shift that happened in we can call it a crisis of Apollo 13, or the incident of Apollo 13, from blame, from trying to understand who to blame, to collaboratively work to solve a problem, is one of the defining characteristics of engineering thinking, and a lesson that applies equally to research, education, business, cybersecurity, and everyday life. So the next time your team faces a challenge, will you spend the time in assigning blame, or will you try step up and work with the team to understand the problem and solve it? Again, everyone is accountable for what they do. Everyone is responsible for what they do. But when it comes to a team, the team must be successful at any given situation. All right, and that's what engineers do. Again, engineers, they think together, they apply research, they apply their knowledge collectively to make things work. Okay, thank you.